This is Math 97, Quiz 4 Topics. Simplifying a product of rational expressions. I want to review this property that says that when we have the product of two roots, that's the same thing as the root of their product. So root A times root B is equivalent to root A times B. So we'll use that in this situation. It says simplify, assume the variable represents a positive real number. Our first example is root 10c to the 7th times root 2c. So using our property, we can combine these into the root of the product, 10c to the 7th times 2c. And then we're able to multiply terms that are alike. And so we multiply the coefficients. 10 times 2 would be 20. And c to the 7th times c to the 1st would be c to the 8th. Okay, next we want to look for perfect squares here. Notice that 20 is not a perfect square, but there is a perfect square that goes into it, the number 4. And so let's break this into 4 times 5 times c to the 8th. And then we think about taking the square root of each separate part. We can take the square root of 4, which is 2. We cannot take the square root of 5, and so we will leave the root 5, the 5 underneath the radical. The c to the 8th, as long as this power is even, we can just divide the power by 2 in order to take the square root, and so the square root of c to the 8th is c to the 4th, because c to the 4th times c to the 4th would be c to the 8th. So this would be our final answer for the first one, 2c to the 4th radical 5. Our second example says root 2b to the 4th times root 8b. Using this same property as before, we can rewrite this as the square root of 2b to the 4th times 8b. And again, moving things around, we can combine the 2 times the 8 and make 16. The b to the 4th times b would make b to the 5th. And now let's take a look for perfect square roots. We can take the square root of 16, so we can leave that one alone. We're not able to take the square root perfectly of b to the 5th because it's an odd power. However, we could break b to the 5th back down into b to the 4th times b, because then we're able to take the square root of the b to the 4th. So then this would be square root of 16 is 4. Square root of b to the 4th is b to the 2nd. We divide that power by 2. And then we leave the remaining b under the radical. So this would be our final answer for that one. Okay, our third example says radical 3x to the 5th y to the 8th times radical 12x y to the 3rd. Let's combine those two parts under the same radical. So we have 3x to the 5th y to the 8th times 12xy to the 3rd. Our 3 times 12 would give us 36. X to the 5th times x would give us x to the 6th. And y to the 8th times y to the 3rd would give us y to the 11th. All right, now we're looking for perfect squares under here. 36 is a perfect square, so we can take its square root. It would be 6. X to the 6th is a perfect square because that's an even power, and so we just divide that power by 2 to take the square root, and that would be x to the 3rd. Y to the 11th is an odd power, and so we could think of this instead as y to the 10th times y. We can take the square root of the y to the 10th, would be y to the 5th, and then that remaining y would remain under our radical. And so our answer for that one would be 6x to the 3rd y to the 5th root y.